to put factoring, and I put make multiplication. Now let's just review a little bit of what we're talking about. And they said it did help yesterday. So let's do 3x times 2x squared plus 4x plus 1. Because factoring is going to be taking what we get here and working backwards and actually making something multiplication. The word we use here is distribute, isn't it? So we've done this in lesson 12. 3x times 2x squared. 3 times 2 is 6. X times x squared is x cubed. Add your exponents. Plus 12. X times x is x squared. And then plus 3x times 1 is 3x. Okay. And in regular Algebra 2, I gave them a sheet of this kind of stuff and asked them to factor it. You're factoring out the GCF when you go this way. The next that you've done in Algebra 1 was multiplying binomials. Two things times two things. When you use the word FOIL, it is a specific for distributing two things times two things. Now, I think Ms. Christensen used the words FOIL. I use them interchangeable, but FOIL only talks about two things times two things. And that a binomial times a binomial. And that's not always what we do. So if you call it distributing, or if you call it foiling, which is the first two, the last two, the inside two, and I think I said it wrong. The first two, the outside two, the inside two, and then the last two. I just say let's distribute it. Let's take this x and distribute it to both of these. And so I'm actually going to write what I do. I'm going to take x and distribute it to x plus 7. And then I'm going to take the positive 3 and I'm going to distribute it to x plus 7. And you get x squared plus 7x plus 3x plus 21. And usually if they're nice pretty ones, especially in Algebra 1, the two middle ones are like terms and you can add them and you get x squared plus 10x plus 21. Now, our goal today is going to be taking a nice, pretty trinomial, 3 terms, that has a 1 in front that we can factor pretty quickly in our head. And then the third, let's do one more of those, and I had a reason for it, is let's take x minus 5 times x plus 5. And it's kind of a special case of foiling. So when you distribute this one, if you say first, which is my distributing the x to the x, you get x squared. If you do the outside 2, I've got plus 5x. If you do the inside 2, you get negative 5x. And when you do the last 2, you get negative 25. Now what's interesting there, and these are actually called conjugates. We'll use that term later as to how they're related to each other. These will add out in this special case, and you end up with not a trinomial, but a binomial, x squared minus 25. So that was just a review of multiplication. Well, factoring is going to be taking these, and we're going to be doing all of these going this way, taking it and making it multiplication. We're going to always look for the GCF, and I'm going to put a star by that one. It's the first, thank you. It's always the first one that we do, and it's the one everybody forgets. So I put a star by it. Never forget GCF, because if there is a GCF, it's got to be taken out at the beginning or the end, and it's always easier to do it at the beginning. But if you don't remember to take it out, you can fix it by getting it at the end. And then the second one are trinomials that do factor. Now, not all trinomials factor. We'll address those later on when we get into more quadratic things. Trinomials with, I call these the baby ones, with leading coefficient. I left something out there. C-O-E-F-F-I-C-I-N, coefficient of 1. Man, it's tearing like crazy. Of 1. And that's what we're talking about right there. See how there's a 1 in front of that one? And then the last one is this one is an example of it, and we want to look at difference of 2 squares. Now that's one that people forget. To me, it's so easy. Ms. Newberry and I talk about this, and it's not just here. Okay, let's start with 8x squared y cubed. Now, we don't do them much with two variables, but I'm going to do one here. Most of the time, we're going to do them with just one variable. And when I look at that, you know, I don't necessarily know what it can be, what it can't be. I know it's not a trinomial because it doesn't have 3 terms, but this is considered a binomial, 2 terms. So I'm going to start and see if it has a GCF. Now, this is the way I teach in Algebra 1. I'm going to put my parentheses. I'm going to put a bar, a blank in front of it. I'm going to put GCF there. And then I'm going to put blank plus blank on the inside. And this is my leftover factors. Normally, I would just look for what they have alike, but I want you to get the concept of what you're actually doing. If you take 8x squared y cubed, just pacify me and write this down, and do its factor tree. Well, the factor tree of 8, I'm not going to go through the birthday cake or upside down birthday cake. I'm just going to go ahead and write it. That's one you probably need to know. 2 times 2 times 2, and you have 2 x's, and you have 3 y's, and that's simply your factorization. You just factored it. You wrote all of it as a factor of prime numbers, and then you've got variables. Now, you also have to recognize there's always an understood 1 in there. 1 is not a prime number. It's not composite either, but it's there, recognizing that when you start talking about GCFs. And then 12x y to the 4th, because sometimes that's all they have alike is that 1. So I'll put a 1 in there, and then I'll put 2 times 2 times 3 times x, and then 4y's. And we did a lot of factor trees in geometry when we were doing square roots, and we'll do them again, but I just kind of want to start there. Well, the GCF is the biggest factors that will go into it. Well, hopefully 8 and 12, you know the biggest number that will go into both of those, but if you look at it, you recognize it as the 2's, and if you want to underline the 1, you can, but you've got 2 times 2, which is 4. Now, when I normally do these without this part, I would do the 4, and then I would do my leftovers in here, then I would do the x's, and then I would do the y's. When I've got it all here in front of me, I'm just going to go ahead and do all 3. So they've got 1x, and they've got 3 y's. Uh-oh, I've left a y out. One of these had 4, this one. Oh, I do have 4. There it is right there. So we've got 1x and 3 y's. Now, just recognize that when you check this, when you distribute backwards, if you don't get the GCF out, it will still work, but it's just not factored completely. I'll talk about that in just a second. What is left over in this factor tree when we take out the GCF? 4xy cubed times what gives me the 8x squared y cubed? Well, we know 4 times 2 is 8, and we took one of the x's out. We had 2 of them, so we have 1 left over, and we took all the y's out. So we have no y's left in this one, and we can check that. Okay, you had 3 y's, and you took all 3 of them out of the factor tree. So let's check that part. 4 times 2 is 8. X times x is x squared. And y cubed times no y's is y cubed. That goes back to lesson 12. Okay. Now the second one, 4 times 3 is 12, and there's my 3. And then I had 2 x's that I took out. Nope, we took out 1x, didn't we? So we have 1x left over, right? Nope, not on the bottom. There's no x's. Looking at the wrong one. We took out 1x, it's gone. And then we had 4 y's, but they only had 3 alike, so there was 1 left over. Distribute that, and you will get the 12xy to the 4th. Now, here's the issue. Let's say you only took out a 2 instead of a 4. You would have a 4 there, and you would have a 6 there. It will still distribute to this, but the problem is what's left in here must have a GCF of 1. GCF has to be 1 of everything left in the parentheses. If it's not, you only got a common factor, not the biggest. There cannot be anything in here that, like, you know, look at 2 and 3. 1 is the only number that goes into both of them. X and Y, they don't have any variables alike. So to know you've got the GCF out, you've got to recognize that what's left in there has to have a GCF of 1. I think you can handle it. We're going to do a couple here in just a minute. We've got 6 examples of this, and then we're going to do 4 of difference of 2 squares. We can run through these pretty quick. Number 2. So we're going to start with x squared plus 6x plus 5. Now, my first thing is, does it have a GCF other than 1? Let me straighten that up. And it does not. X times x, 2 times 3 times x, and 1 times 5. There's nothing that will go into any of those except 1. That's all you would have underlined in their factor trees. So I immediately, because I did not give you any that will not factor, if you look back up at this one that we did up here, if you're going backwards, look at where your numbers came from. You had x plus 3 times x plus 7, which gave you the x squared plus 10x plus 21. Well, your x squared is the x times x. That was your ELF of your FOIL. And then the 21 was right here, these two. And then when you did the 2 inside, the 7x and the 3x, that gave you the 10x. So we just go backwards. X squared has to be x times x. See, when you check it, ELF, x times x is x squared. Now, to get these two numbers, you want to go to this one first. And you need a factor tree of 5. Well, 5 actually is prime, so the only factor pair that gives you 5 is 1 times 5. Now, we know that when we distribute them to the x's, we'll have 1x and 5x, and do those add to 6x? They do. So if I put plus 1 and plus 5, let's check it. Now, I'm not a big proponent of checking because most people just rewrite the problem. But let's literally check it. X times the x plus 5 is x squared plus 5x. And the 1 times the x plus 5 is 1x plus 5. And when you add those together, there's your x squared plus 6x plus 5. Now I have a question for you. Could I have written it as x plus 5 times x plus 1? They can still multiply the same because they are, multiplication is commutative. You can multiply both ways. Number 3. X squared minus 8x plus 7. We're only doing coefficients of 1 today. So x squared's got to be x and x. GCF is 1. I got to keep that in the back of my mind. I need factors of 7, factor pairs of 7, which is 1 times 7. That's all I have. Now, how can 1 and 7 add to be a negative 8? They can both be negative because a negative times a negative gives you a positive, and they add to be negative. So if you put negative 1 and negative 7, or vice versa, then if you distribute it back, see, there's your x squared, there's your positive 7, and then the negative 1x and the negative 7x add to negative 8. Number 4. K squared. And please use the letter they do. I'm not going to count it wrong if you put x's, but it's just a good idea. K squared's k and k. GCF was 1. Do I already know what the sign should be? Yeah. If everything's positive, they're both going to be positive. And I usually go ahead and address that. Now, I want you to write this on your paper, even though you probably already know the answer. Because what you're actually doing is, I said a while ago, you've got factor trees, you've got factors, and then you've got factor pairs. And what we need here are the factor pairs. 1 times 36, write these down. 2 times 18, 3 times 12, 4 times 9, 6 times 6. And one of those, if it factors, and I only gave you ones that do, have to add to that middle number and when you distribute them to the k's. So we're talking about like 1k 36. There's no way those can add to 12, and you can see it should be 6 and 6. Now I gave you that one especially. That's called a perfect square trinomial. We use those a lot later on, but I'm going to put or instead of equals because both of them are acceptable. But that can also be written as k plus 6 squared, and we actually use that notation later when we start doing square roots of things. That's my or there.